Okay, we have here today another integral from the MIT Integration Bee 2025, number 6. We have the integral from 0 to 2 pi of all the trig functions multiplied together dx. Okay, this one's going to go really quick. What we really need to do is we're going to be able to simplify this. I think maybe a good place to start is with just this tangent and cotangent right here. Cotangent is going to be the same thing as just the reciprocal, cotangent's the reciprocal of tangent. So when you multiply these two together, that's just going to cancel down to a 1, so we can get rid of that. But we can do the same kind of thing with all over the place here, like secant is 1 over cosine x. So if I multiply cosine times secant, that's going to be a 1. But also cosecant is 1 over sine x. Sine times cosecant, that's going to be a 1. And so what just happened, this whole integral is going to be just integrating 1 dx. Go ahead and integrate it. What's going to happen? We get x from 0 to 2 pi, plug in, and so the solution of this is just 2 pi. So as you can see, the qualifier is a bit too easy. Let me do another one. I've done this quite a few times on 2025, maybe grouping two problems together. I kind of like doing all of them. I kind of like to do all 20 of the qualifier, but I also don't want to do a 30-second video, so let's look at problem number 7. Okay, for number 7, we've got the integral of x ln x cosine x minus sine x over x ln x all squared dx. For this one, the first thing that comes to mind is the reverse quotient rule. For the quotient rule, we have this formula. If we're taking the derivative of f over g, the formula is just going to be f prime g minus fg prime over g squared. So it seems kind of reasonable where we've got something squared here. We're subtracting terms. You know, we've got the ln x. It seems like we've got possibly some derivatives. The trouble is, you know, we would kind of like this x also to be squared in order to be able to have a very simple g. But what I can do, I guess I could do it two ways. One way I could multiply in an x in the numerator and denominator. Then what would happen is we have the whole denominator as x ln x squared. I didn't really try it like that, so let me know if that way is better, I guess. But instead, I think what I want to do is let's just get rid of this x by multiplying it in. Multiply it in here, and I need to also multiply it in here. Divide it into the numerator. So when I rewrite it, let's see what we have. Dividing it in here, it's just going to cancel out this x. So we're going to end up with just ln x cosine x. Everything's going to be over this ln x squared. And then dividing the x in over here, I'm just going to write it as minus 1 over x sine x. Now this is starting to look pretty good. We've got our something squared. If we call this g, then our denominator matches. So let's just see what's going on. We're going to say g is going to be ln x. Then we can take a derivative, and we're saying g prime is going to be 1 over x. So that's kind of nice because we've got the 1 over x right here. So that's going to match the g prime in the formula. For this f right here, for this to work, we're saying we want f to be equal to sine x. Then let's take a derivative on this. So for f prime, this is going to be cosine x. So we need f prime g. That needs to be cosine x ln x. That's exactly what we have right here. So we notice we've got everything perfectly set up. We know all of our values. For the quotient rule, if we think about it like we're integrating this thing, over here on the left side, we're integrating a derivative. What's going to come out is just going to be fg plus c. That's going to be the format for our solution. So all we need to do to finish is just grab the f value, grab the g value, put it together. And so for my final solution on this, we get just sine x over natural log x plus c, and that's it. Okay, so there you go. Problem 6 and 7 from MIT 2025. Thanks everyone for watching. Have a good day.